All right, today we're in section 8.7, operations and scientific notation. All right, there's a couple really important concepts. We're actually not going to see this until we do part 2 of the lesson, but I'm going to go ahead and have you write it down. This is a really important concept here, that you cannot add or subtract in scientific notation unless the exponents are the same. All right, I like to compare that to like common denominators. In order to add a fraction, two fractions together, we have to have a common denominator that we carry over into our answer. The same thing applies with adding and subtracting numbers in scientific notation. All right, we have to have the common exponents when adding and subtracting, but we don't have to have them when we're multiplying and dividing. All right, so that's really important. The second really important point, and we're actually still going to do some of this today, even though we're not, even though in part 2 this applies a little bit stronger application, you're going to see some of this today as well. That in order to increase the exponent value, so if you have to have the same exponent, well, how do you make the exponents the same when they're not? Basically, for every number, every digit that we increase the exponent by, 10 to the 3rd power up to 10 to the 4th power, we will move the decimal left in the decimal value that is being multiplied. Okay, so I'm going to give you a chance to finish writing that down, and then I'm going to explain here what's happening in this example. Okay, so in the first number written in scientific notation, we have 2.3 times 10 to the 3rd. So if I needed to raise my exponent from the 3rd power to the 4th power, my rule says that I can move my decimal to the left however many places need to be increased. Okay? So to go from 3 to 4, does everybody agree that's increasing by 1? Does everybody agree? So that's why I would move my decimal to the left 1 place, and now I have 0.23. So that's what we're showing you here. If I need to increase my decimal values, then I can move the decimal in the number to the left, and it basically cancels it out, or it offsets the change. All right? Okay, so that's really important. Now let's switch over to example 1, and we'll see what's going on here. I need you to write down these 2 problems. Okay, these 2 problems side by side at the top. All right, exactly how I have them written on the screen. Go ahead and write them down. So let's look at the first problem. All right, so here's what my rule says. Okay, the very first thing I look at, and you can tell by the title to this slide that we are going to have it, but I still want to kind of train you or teach you to check for it first. Do we have the same exponent in both sets? Do we have the same exponent? So because we have the same exponent, it's like adding a fraction. We're going to add our decimal values together, and we're going to keep the common exponent. Okay? So we're going to go 4.6 plus 8.72. And we know that adding decimals, we line up the digit or the decimal. We line up the decimal point. That is extremely important. If you don't do that, you're at risk for getting the problem wrong because you are not using calculators. So this is going to be work that you have to show, all right, just to get to the answer. So it shouldn't be a question, well, do I need to show my work? Well, my answer would be yes to get to the answer, right? We're not doing this mental math. So if we add them together, 0 plus 2 is 0, 6 plus 7 is 13, and 5 plus 8 is 13 when I carry my 1. I guess I could write that 1 that I carried up there. Okay? So when I add my decimal values together, I get 13.32 times 10 to the 3rd power. Again, I just bring my common exponent down. 13.32 times 10 to the 3rd power. So I have simplified my decimal values, but I'm not finished yet. Because in order for this number to be in scientific notation, my decimal value has to be greater than 1 and less than 10. Is that number less than 10? No, it's not. And a lot of times when you're adding and you add them together, now your number is greater than 10. So you have to move your decimal to the left one place in order to get that number back in the correct range. 1.332. Now, would you agree that number is greater than 1 but less than 10? And do you remember what I said in the last slide? What happens when we move our decimal to the left? What happens to our exponent value? It would go up by 1 because I moved it to the left 1 decimal place. And that's going to be my answer.
So if you move it like to the left 5,
then you would up it by 5. But that won't ever happen because in order for it to be written in scientific notation here, my numbers have to be less than 10. So you're never going to be adding like numbers in the tens or even the hundreds together because those numbers up there have to be in scientific notation. So at the very most, you're going to be moving 1 decimal place. Okay? Or sometimes none at all. You just have to check that. All right, you see what we're doing? Okay? Now, what's different about the second one? Now we're subtracting. All right, so the odds that we have to do anything at the end, like that our number is going to be more than 10, is pretty slim. Okay? But now, again, the first thing I want to check for, do I have the same exponent? So now I can just combine my decimals. Okay? As long as I have the same exponent, I can just combine my decimals and get to my answer. 7.8 minus 4.5. Go ahead and subtract those two numbers. What did you get when you subtracted them? 3.3. And again, we can just double check, is that number in the range greater than 1, less than 10?
yes.
Okay, so now we're going to rewrite it. 3.3 times 10 to the negative 5th power. We bring down the common exponent, and we're done. 3.3 times 10 to the negative 5th. If we have the same exponent, we combine our decimals, and then we can write our answer. All right, next example, we're going to do multiplication. Okay, so with multiplication, we follow a different set of rules for the exponent. The exponent does not have to be the same, and 9 times out of 10, it's not going to be, and that's okay. With multiplication, we follow a different set of rules, just like multiplying fractions. I don't have to have an LCD. Multiplying scientific notation, I don't have to have the same exponent. But what I can do is I can group using commutative property, meaning I can reorder these numbers. Does everybody agree that I'm multiplying each number basically together? It's all multiplication all the way across. Everybody agree? It's all multiplication. Because it's all multiplication, I can rearrange these. I can group my numbers together. 3 times 5. Because I could do 3 times 5 pretty easy, right? A lot easier than I could do 3 times 10 to the negative 5th power and simplify it. So we can do 3 times 5, and then we can group our tens together. 10 to the negative 5th power times 10 to the negative 2nd power. All right? And now I can really see a lot more clearly how I can simplify this. Right? What's 3 times 5? 15. Does anybody notice something that might be in common with our second set of numbers? They have the same base. So because they have the same base, what can I do with my exponents? Add them together. What is negative 5 plus negative 2? Negative 7. Negative 7. Do you see what we did there? All right, same base. And guess what, guys? It's always going to be the same base because it's scientific notation. But is this my final answer? Hold on to it for just a second. Is this my final answer? Why? Because 15 is greater than 10. You have to check. This would be my final answer if 15 was less than 10. Okay? It would be my final answer. But because it's not, what do I need to do to my decimal point? move it to the left one place, to 1.5. Now I have it in the correct range. But do you remember what we said? If we move it to the left one place, what happens to our exponent value? We add 1. So yes, -7 plus 1 is -6. Okay? And that would be my answer. All right, so you always have to check at the end, is my number in the range between 1 and 10? If it's not, then we have to move the decimal and change our exponent. Okay? Any questions? Just walking around, I think everybody's doing okay on the second one. Let's go ahead and go over it. All right, so again, we're going to group 12 times 6 together, which is 72. And then times 10 to the 4th times 10 to the 8th is what? 10 to the 12th power. But is this my final answer? No, why? 72 is too big, right? So if I need to move my decimal to the left one place, what happens to my exponent? It goes up 1. Okay? It goes up 1. 7.2 times 10 to the 13th. Who got that right? Who got it right? Or maybe you got it wrong the first time, but then you got it right before we went over it? Good. All right, so that's example 2. All right, example 3. Dividing in scientific notation. Go ahead and write both of these down, both of these problems. Down, we have one written as a fraction, and then we have the other one written side by side. You're going to see both formats, so we need to make sure that we're on the same page here. So we're going to divide. What I want you to start off by doing, and kind of like what we did with multiplying, you're going to split the fraction, okay? So you're going to show 1.8 divided by 6, and then you're going to show 10 to the -8 divided by 10 to the 7th power. Sorry, I'm just trying to find where that went. Whatever. All right, I'll just rewrite it. I lost it. 1.8 divided by 6 times 10 to the -8th power over 10 to the 7th power. Now we can more clearly see I can divide 1.8 divided by 6. There's no way around it. You will have to do some long division, but what I can promise you that I'm going to try, at least on your quiz and test, these will not be very long, like decimals. Like you're not going to go out 4 decimals or something ridiculous, but you are going to need to divide. 1.8, we know that the numerator goes on the inside, divided by 6. And as long as there are no decimals in my divisor, I'm okay to leave the decimal in my dividend, the inside number. Does 6 go into 1? So a 0 goes there. Does 6 go into 18? 3. So that's really going to be the extent of your long division. Maybe 1 or 2 decimal places. All right, so now we have our 0.3. Now we have to do quotient of powers here because we have the same base. So do I add or subtract my exponents? Subtract. So -8 minus 7. I bring up my 7 and subtract it. What's -8 minus 7? Yep, -15. So 0.3 times 10 to the -15th power. But this is not my final answer because now I have, on the opposite side, I have a number that's too small. It's not between 1 and 10. So which way would I need to move my decimal? To the right. All right, so let's kind of try to flip it a little bit. When I moved it to the left, I increased my exponent. So what do you think is going to happen if I move my decimal to the right? I'm going to decrease my exponent by 1. 3 times 10 to the -16th power. All right, and that would be my answer. Okay, All right, let's try to set up the second one. We have it written side by side. I want you to write your numbers in a fraction and your tens bases in a fraction, just like we did here on this step one. I want you to try to do it on the second problem. This will be our last problem for the day. All right, so we've got 1.5 over 7.5 times 10 to the negative third over 10 to the second power. All right, so let's start off by dividing 1.5 divided by 7.5. No matter what the numbers are, 1.5 is clearly smaller, but because it came first, it must go on the inside. If you switch it, you're going to get the answer wrong, okay? So it always goes in that order. Now, my rule says I cannot have a decimal in my divisor. What can I do to move it out? Move it to the right how many places? Do you agree if you move your dividend to the right one place, it moves your decimal out of the number on both? Do you agree? Everybody agree? If I move this one to the right and this one to the right, it's now after the ones place. So when you have the same number of decimals, you can just erase the decimal. All right, and it's the same thing. Does 75 go into 15 at all? No. So you're going to put a 0 for your placeholder, and you're going to add a 0 after the 5. Does 75 go into 150? Yes. How many times? 2. Okay, so now you've simplified your decimals to 0.2. Now simplify your tens. Go ahead and do your tens. So when we subtract negative 3 minus 2, guys, you've got to be mindful of your signs. Negative 3 minus 2. If you spend $3 and then you spend $2 more, you spent $5. Okay, so when it's negative, you add and keep. Negative $5. Negative 5, okay? But now this is not my final answer. Why? This is not my final answer. Tell me, Caleb. It's not above 1, so I must move my decimal to the right. And my rule says when I move my decimal to the right, what does it do to my exponent value? Increase or decrease? It decreases when it's negative. That means it's going farther away from 0, so it's 10 to the negative 6 power. All right, and we're going to stop there. All right, so that's part 1. We do have one more example that we'll cover tomorrow. I've modified your homework to take out this last example, so numbers 12, 14, and 16 you will not have to do, and I will update the portal. And that's it for part 1 of 8.7.